piled higher and deeper. Tony Purcell, geophysicist, 22 July, 2020.
Trees convert carbon dioxide, which is a gas, into oxygen, which is another gas.
No. Wrong-o-rama. Plants don't use CO2 to generate oxygen. All the oxygen generated or liberated comes from the splitting of water by photosystem II during light-dependent reactions. We knew this 80 friggin' years ago. It's called the Hill reaction. Dummkopf. Apparently you've been swapping spit in the shower with the photosynthetic redneck, aka hillbilly blue balls, the redneck retard, that made the same stupid mistake.
So trees don't create gas.
But no, they don't. Be careful. I got yelled at about that now. So just to be
really? Who by?
Just to be very quantum eraser.
I'm your huckleberry. That's just my game.
Just to be very specific, QE, if you're listening, you little son of a bitch.
Hi there, numpty.
We're not saying that trees break carbon dioxide up into carbon and oxygen.
That's exactly what that moron said. Let's take a listen.
Trees convert carbon dioxide, which is a gas, into oxygen, which is another gas. Trees convert carbon dioxide, which is a gas, into oxygen, which is another gas.
Ergo, he is another photosynthetic redneck numpty like you.
For me, it boils down to a gas molecule at Earth's surface has finite energy.
What in the world did you get yourself into now, Dummkopf? Finite energy? What does it do? Reach the end of the line of finite energy and rip off its bra in rebellion of gas law and the second law of thermodynamics? Time to fall down, go boom, boom, go splash, splash. Hey? Numpty, the average kinetic energy of gas particles is proportional to the absolute temperature of the gas or gases. My word.
Entropy is not a source of infinite energy that will give, that will allow a gas molecule to travel an infinite distance in an arbitrary direction. Conservation of energy is the primary natural law that everything needs to obey, and even entropy is subject to it.
Let's first deal with the Helen Keller T-Rex in the room right here.
A gas molecule at Earth's surface has finite energy. Conservation of energy is the primary natural law that everything needs to obey.
You dumbass.
OMG. From a geophysicist, PhD. D for dumbass. Thanks. You chief delusional Dunning-Kruger ball-tart photosynthetic redneck pretender clown fuckwit of megalithic proportions. You kind of just contradicted yourself?
Uh-oh!
Dummkopf. Conserved quantities in physics mean that certain physical properties, that is, measurable quantities, like momentum and energy, do not change. You just said
a gas molecule at Earth's surface has finite energy.
Meaning the gas molecule lost its energy. It changed? How then can you invoke the conservation of energy? It wasn't conserved. You have like a 1948 physics glossary and you're just flipping pages, eyes and retard mind shut, and wherever your doofus finger lands, you name or phrase drop them into your yarn? then have the skank-and-file ball-tard morons ooh and ah over it? Ladies and gentlemen of the jury, his quarter-stick dynamite up the ass, sit down on a bonfire, full-tilt belly laugher is exactly like attempting to rally support to justify British colonial rule by organizing town hall meetings in Boston and Philadelphia, canonizing the Declaration of Independence. You're a meatball. Tard. The rest here is just globe-tard goober gravy. Nobody said entropy was an infinite source of energy because it's a moronic statement and an incoherent straw man. Natural laws don't provide and are not sources of energy. The second law of thermodynamics isn't a conservation law. So to say a non-conservation law follows a conservation law is dummkopf and batshit insane. Of course, entropy doesn't create or destroy energy. It doesn't have anything to do with the topic. This antiquated physics glossary, pin the tail on the numpty PhD ball-tard clown show charade, is fixin' to be eclipsed, if you can believe it.
Just when I think you couldn't possibly be any dumber, you go and do something like this. And totally redeem yourself!
So this is what I lack.
Brains?
So I believe I stated over and over again is, I'm a mathematician who has become a geophysicist. I am not overburdened with a technical understanding of a great deal of physical reality, as it might be termed.
Are you serious? Are you serious? Hey!
Hello. It's for you.
Yeah?
You've just been erased.
Hey, what's going on out there, guys? Welcome to the show. Got some fire for you today. As usual, if you'd like to support this channel, there are PayPal and Patreon links in the info box below. Heading on Discord, where I was all by me onesie for a long time. Let's see if there's anyone in there. I haven't checked in a little bit. Is the beautiful Betty Van Velsen somehow in Discord now?
Yeah.
Ah, there you are. Way to hesitate.
Well, were you worried that I didn't want to show up?
Yeah, I was sweating bullets and I started shaking uncontrollably.
In your boot?
Yes.
Like a little puss?
Oh, that's almost like an F-bomb.
Puss in boots.
Puss in
That
boots.
fairy tale thing, right?
Yeah.
You fell right into that one.
Yeah, I did.
Yeah. You got a super chat already.
Oh, really?
Ja, dat is ook famous as red, blue, white, black, green, yellow, gray, orange, done.
Oh, I think I get it. Of course, black isn't one of the colors. Neither is gray, but you're in the vicinity. You know what he's talking. You know what he's talking about.
For the prisms.
For the no, he's not in prison.
Prism. Unbelievable.
Yeah. It's
Okay.
Roy G. Biv.
The what?
Roy G. Biv.
Biff?
Biv, not Biff. Biv.
How do you spell that?
Roy, R-O-Y, and then a G, and then a Biv. It's an acronym. It's a mnemonic for the light spectrum.
The latter word you didn't spell.
Oh, I'm sorry. Okay, I'm going to give it to you. So, Roy, Romeo, Oscar, Yankee. G is in golf, and then Biv, Bravo, Indio, Violet. Oh, it's not Violet, Inspector. I'm sorry. Violet is what it means.
Violet?
Yeah, Violet.
Violent or violet?
Oh, jeez.
So it's Biff with a V and not with a F.
That's what I said at first. It's not Beth. It's Biv.
It's hardly any difference.
Oh, the difference is a V versus an F.
Well, you got another super chat.
Let's get it.
I might be reading these things bad, I think. Unit Xfemu again. He says R with capital letters. RGB Betty in capital letters. Roam and smell.
Round and smell. That's really good. Thanks, Unitox Memo. Yeah.
What is it?
I don't know. You're gonna have to ask him.
Oh, he says brown. It should be brown in smell.
Oh, brown and smell. Well, that's really profound.
What does RGB mean?
What do you mean RGB?
Oh, is that the oh my god. The
Red,
acronym.
green, and blue Betty.
Oh. See, I'm at a loss for this.
That's okay. Most people
And
are.
Nathan says you may begin, so that's good.
Well,
I'm
thanks.
going to shut down. I'm going to begin.
Welcome back, Nathan. I'm glad your daughter is okay. Yep. So we'll begin. So where are we going to start at?
I'll start with green.
Green is a good color. OD green is not. That's sort of a military color. I don't like OD green, but the different shades I do.
In OD?
I love getting that echo, and I'll bet you it's from you.
Well, that's good, because usually I get them from you.
Yeah, that's right. In Skype, Betty gets the echo from me, and then she returns the favor in Discord, and then just rushes the show with it.
Yeah. Well, you got another super chat.
Really?
Yeah, Unitox Famous had a role here. If you see color, that means you can know how smells.
That's profound again.
That's exactly what I thought.
Is that what you said? Yeah. Okay. We can roll with that. Just keep on. Honey, we got another super chat.
Nice, huh?
Don't worry about it. My son's hollering, honey.
Okay.
Yeah.
So,
yep. Somebody said the olive drab in chat, and that's correct. The old olive drab. Yep. Go ahead, Betty. I rumpused you.
So you're going to start with green?
Gonna start with what?
Green.
I'm not gonna start with a color, no.
Ah. So where are we going to start then?
That's a good question, and I think I'm sitting down on the job talking to you guys because I have to go. I forgot I had to go get something, so go ahead and carry on. I'm still here. I'm still here. I just got to grab something from.
Okay, then I'm going to introduce Adam.
Go ahead.
Hey, Adam, you come into the chat.
Evening.
Hey, evening.
The nomenclature we used was Richard of York got boiled in vinegar.
Vinegar?
Yeah.
Sorry, Adam, you have to repeat that. I didn't understand.
Richard, red, of your got boiled in vinegar? Remember the colours.
That's another acronym, Betty. It's the same.
I'm out for the day. Just don't address me. I'm
Well,
no good.
Okay, that's not an acronym. It's more of a mnemonic. It's the same thing as Roy G. Biv, but he just put words to it.
Yeah, I'm out. Like I said.
Yeah, that's okay.
So when you need me, you can call on me. But I will be here in the background.
That's fine, and I found what I was looking for, and I think I got it. Put that right there, and we will save that for later, and you'll see why. Okay.
So you're going to do a presentation on spectroscopy.
Spectrochocoloscopy, get it right.
I can't say that because then I will never be able to say spectroscopy again.
Remember the original one from Toady? It was I can't even remember it.
Oh, here, there you go.
I got it written down. I think I got it written down in the presentation, so when we get there, you'll know what I mean.
Another super chat.
Sweet.
He says, "How you to explain how spectroscopy will form curvature in reality?" Question mark.
Damn, he just slamming the super chats, and that's nonsensical statement.
Yeah, if you get some words, I suppose.
What's going on? Oh, by the way, I just want to announce that before we get into the presentations, which is going to be most Ricky Tick. I did experiment, quote unquote, with different recipes for the crappies, and I've definitely found the outer batter, and it is crushed salt and vinegar chips. There's nothing better. Listen up out there. If you want to batter fry fish, crush up some salt and vinegar chips. Now, I used an egg batter, an egg wash. Next week, I'm going to do a mustard wash and use those same salt and vinegar. The salt and vinegar chips are staying. I'm just telling you right now. They're not going a damn place. That's how good it was. So I just wanted to update the crowd just in case, you guys were wondering.
Some gourmet stuff now.
I'm telling you, I crushed them.
Chips.
I'm telling you, I took the damn rolling pin, right? I put a bunch of chips in the plastic bag, and I took that rolling pin to it. I treated those chips like a baller.
Are they in batter or just?
No,
they all the batter.
No. Now listen, this is what I did. I crushed all those chips. First, I checked all the fish for bones. You got to do that because they were quickly filleted out in the field. So what I do is I dry them up and then check them for bones. They did a really good job. I only found like a couple here and there. So I removed them. And then what I do, I got, an egg wash, scramble some eggs, and then just soak them in an egg wash for about 5 minutes. Leave them in there, and then take those crushed salt and vinegar chips and toss them in that bag, that plastic bag. Give them a roll or two in there, and it sticks to the fish. And then drop them in the iron skillet with canola oil. Look the heck out, man. Look out. I'm telling you, man. My wife took one bite of a good one, right? She took a small bite of a real small one. It was just the crunchies. It wasn't that good. But I had the mother load on my plate, and I said, come on over here. I said, taste this one. And you should have seen the look on her face, right? And the smile that started to erupt. That's when I knew. Of course, I knew that before that, but you know what I mean. So that's the deal. So next week, I'll give you an update next week. We're going to use, instead of the egg, so I'm going to use mustard. Just regular yellow mustard, nothing fancy, not gray poupon or anything. Just yellow mustard.
Did you say gray poupon?
Yeah, gray poupon, yeah. Yeah. All right, let's see what we got here. We're going to be talking about spectroscopy. or spectrochocoloscopy, as we affectionately call it. Shout out to Adam and Chocolate. And I think this is the third or fourth time I did a presentation on this, somewhere in that vicinity. And we're going to go over, I'll tell you what, folks, this is a real belly laugher. Now, not spectroscopy itself. The belly laugher is the surrogate that's attached to it that the ballers use. Not only the ballers, it's all the pseudoscientists that don't know their ass from a pipe wrench. They associate celestial spectroscopy, which is, I'm telling you, this rivals evotard evolution. You're going to see why here in a few minutes. Now, I'm going to brush over a few sections because I went into it in detail in the last presentations that I did. So those things that we brush over, you can always go back. Just go to my playlist. It's in there. Just go back if you have any questions. You can just listen to that over and over and over again, and you'll get it. And I'll let you know. We're going to start off by brushing over some few minor things. They're major things, but we're not going to major on them today. So save a little bit of time. Is everyone good? Everyone good with that?
No, first a super chat.
Go.
Okay, from Tony Whitcomb. He says the warping and bending of Soa's time sounds like what happens in a baller's cranium.
Thanks, Tony. The warping and bending of Soa's time? Oh, Ace? Sounds
Soa's.
like what's happening in a baller's cranium. Why did my screen just flash?
Maybe it wants to wink at you.
I'll give it a wink.
You give it a whack.
That was creepy. Okay, I'm good to go. Hey, thanks, Tony. Appreciate that. I'm still live. We're all good. Betty, you hear me?
Yeah, I do, but maybe not for long.
That was pretty strange. All right, you know what? Let's get into this.
Let's do that, yes.
Okay, let's roll on over. Let's see what we got. Okay, like I said, spectrochocoloscopy. Basically, it's the interaction of light with matter, specifically with respect to emission and absorption of radiation, right? If we can boil this down, we can tell different elements by their signature or their fingerprint. That is to say, each element has its own unique fingerprint, like us. It either absorbs or releases energy. That is either a bright line spectrum or a dark line spectrum. They're opposite sides of the same coin. So, and it's all based on quantum mechanics. I mean, this is really rock solid quantum mechanics. Each element has so many energy levels that those electrons, if they're in the ground state, that means in the relaxed state, that they can enter in, and each element has its own unique energy states, right? And then when those electrons get up in those energy states, the higher they go and then they fall, they release light or absorb. When they release light, it's an emission spectrum. When they absorb it, it's when they're at the ground state. So I just brushed over all of, or a good portion of the understanding of quantum mechanics. And there's a better picture there for you. This is hydrogen, and it's unique to hydrogen, right? And it's based on hydrogen's energy level. So they know all of the elements because they put them in a spectrometer. And we're going to see those exact spectrometers down here in a few seconds. And then we're going to juxtapose it with the fairy tale celestial spectroscopy. This is a real belly laugher, folks. Get ready. So, there are three main types of spectra: continuous, emission, and absorption. Pretty easy. Continuous, well, this is all continuous. I think it's a perfect pictorial of that. Absorption is just like how it sounds. It's a dark line spectrum, right? So whatever is happening here, it's getting absorbed, right? And then on the flip side of that is the emission spectra. Notice with this particular element, they're the same coin, but flip sides, right? You see where the lines are showing up in the emission spectra? Well, those same lines show up in the absorption spectra, right? Flip side of the same coin, like I said. So, continuous spectra are produced by energized solids. Continuous spectra are produced by energized solids. Now, there's plasma with caveats. The biggest caveat is the plasma must be in a container. Pretty big caveat. Emission lines are produced by energized thin gases. And absorption lines are produced by cool thin gases. With the light source, in this particular caveat, with the light source in line radiating them. And I'm going to show you this towards the end of the presentation, but it's an in-line type of thing. That means the light, the gas, and you are in a line. All right? Good. Very important learning objective, and you're going to be seeing this throughout the presentations. Or the presentation in this particular case today. Gases only emit and absorb in bands. Yeah? Very important statement right there. Gases only emit and absorb in bands. Remember the emission and absorption spectra? Emit and absorb. Yeah, you guys catching it? But these gases only do it in bands. Now, for the juxtaposition, we have atomic emission spectroscopy, that's AES, and atomic absorption spectroscopy, that's AAS. These are what we call terrestrial spectroscopy. These are legitimate. Okay? This is done throughout the world. There's no issue with it. However, we got its incoherent cousin. Somebody just made this up. Astronomical spectroscopy. This has absolutely nothing to do with terrestrial spectroscopy. I'm going to show you why. All right, here we go. Terrestrial spectroscopy. Like I said, atomic emission. You have flame, inductively coupled plasma, electrothermal. Inside a frigging machine, it's closed system and highly controlled. See this? This is an inductively coupled plasma atomic emission spectrometer. Right? You see, it's kind of a closed system here. This is highly controlled, folks. If you don't highly controls the ins and outs and what have yous, then your data that you get from it is going to be compromised. Right? But I wanted just to show you that it's inside, the most important thing for us today, that it's inside a closed system, right, to be tested. We went over this before in the previous presentations. Like I said, if you want to read up on the ins and outs and what have yous, I went over it in the other presentations, so go there. Give step-by-step instruction on how these work. Then we have atomic absorption spectroscopy. So that's flame, cold vapor, hydride generating, and graphite furnace inside a friggin' machine again. It's closed system and highly controlled. This is a flame atomic absorption spectrometer. See the closed system here? And it's highly controlled. And like I said, we went through on how these work in previous presentations. Catch up with them at your leisure. So now we're going to juxtapose it with its twisted sister, celestial or astronomical spectroscopy. Remember what I said about terrestrial? It was in a closed system and highly controlled. This is just the opposite. So it's an open system and not controlled. All the unknowns and millions of potential confounding variables between you and the sun. This is going to become very important in this presentation right here. Remember this little statement. Because we're only focused on the sun here, nothing else. Okay? But that is a very important statement. This is the McMath Pierce Solar Telescope at Kitt Peak. This is what they use to come up with their absorption line spectra that we're going to see below here in a few minutes. So this is what they use. Does this look like a closed system to anyone? You might want to define closed system. Peradventure. The number one belly-laughing train wreck, and there's a lot of them, but this is the first one. You guys see the elephant in the room. I stressed it before. And it's merely just one. Actual spectroscopy, AES and AAS, emission and absorption spectra, are conducted in a closed system, and it's highly controlled. Celestial spectroscopy, on the other hand, is an open system and no control whatsoever. So I can pretty much prosecution rest right there. Obviously, we're talking about different animals with the same name. Another feebly contrived, clumsy Dunning-Kruger bait and switch. In other words, it's an equivocation fallacy. The clowns say spectroscopy, using the veracity of actual spectroscopy, the terrestrial variety that we went over above, to give credence to their fairy tale celestial spectroscopy via Elmer Fudd linguistic association with the word spectroscopy. It's a simple doofus equivocation fallacy and Mr. Magoo false equivalence fallacy. That's all it is right here. It's just a game. A word game, linguistics game. I'm going to show you in spades. I already showed you most of it. Wait till we get to the punchline. There's one big punchline and then sub-punchlines that are just as devastating. Number 2, belly laughing train wreck. This is from Focal Peter, Solar Astrophysics, and from Cool Cosmos, Infrared Astronomy from California Institute of Technology. Listen up, folks. Astronomical spectroscopy, which is celestial spectroscopy, is used to measure 3 major bands of radiation: visible spectrum, radio, and X-ray. While all spectroscopy looks at specific areas of the spectrum, different methods are required to acquire the signal depending on the frequency. Ozone and molecular oxygen absorb light with wavelengths under 300 nanometers, meaning that X-ray and ultraviolet spectroscopy require the use of satellite telescope or rocket-mounted detectors. Yeah, I'm sure they do. Radio signals have much longer wavelengths than optical signals and require the use of antenna or radio dishes. Infrared light is absorbed by atmospheric, contradiction in terms, water and carbon dioxide. So while the equipment is similar to that used in optical spectroscopy, satellites are required to record much of the infrared spectrum. So, since X-ray, ultraviolet, and infrared spectroscopy require satellite and rocket-mounted telescopes, that is, they need to travel into a second law thermodynamics violation, aka telescopes in Narnia, they're shit canned. Follow? Since our focus is on the sun, radio spectroscopy is also shit canned. So, section summary. When the incoherent hordes of clinical-level Dunning-Kruger pretender clown wiki Discovery Channel parroting, spinning ball-tard space monkey window lickers respond with spectroscopy or spectroscopy. That's the one. Spectroscopy. That's Toadie's one. That's the one I was searching for earlier. When challenged with, how do you know what the sun is made of, you can now laugh uncontrollably in their crayon-munching faces. And I could stop right here and prosecution rests. But where's the fun in that, right? Remember, key learning objective. Gases only emit and absorb in bands. Okay? Number 3, belly laughing train wreck. This is a really good one. So this is from nasa.gov. Pay close attention. The spectrum of the sun appears as a continuous spectrum and is frequently represented as shown below. This type of spectrum is called an emission spectrum because what you are seeing is the direct radiation emitted by the source. In the case of the sun, light is emitted at almost all energies in the visible spectrum, which is why you see all of the colors in the sun spectrum. Everyone got that? That's continuous spectrum. We've seen it above at the beginning of the presentation. Yeah, you got that part? Yeah. Remember I said this is the absorption line spectrum from the Pierce-McMath telescope from Kitt Peak. This is what they gave everyone, right? It's also the same source that I got the citation up above here. We're all on the same source, right? Wait a second. They're calling this a continuous spectrum. They said the sun appears as a continuous spectrum. Does this look continuous to you? Doesn't to me. This looks like an absorption line spectrum. Huh. Interesting. Question. How in the flying Fukuyama can the sun give both continuous spectra and an absorption line spectra, por favor? Does the sun have its own no-atmo day too? Okay, now listen up. They're going to contradict themselves again. From the same source, from the same paper. When the light leaves the surface of the sun, it is very nearly a continuous spectrum. What? Didn't you just say above it was a continuous spectrum? I digress. It is very nearly a continuous spectrum. However, as it passes through the sun's atmosphere, that's a contradiction in terms, gases, and a second law of thermodynamics violation, gases present in that atmosphere absorb specific wavelengths of light, leaving the pattern seen in the spectrum above. By studying those lines and matching them to the known lines from elements, astronomers are able to determine what gases are present in the sun's atmosphere. Here it is, folks. So, NASA, can you make up your mind? A, the spectrum of the sun appears as a continuous spectrum, which is why you see all of the colors in the spectrum. And just beneath it, B, when the light leaves the surface of the sun, it is very nearly a continuous spectrum. Make up your mind. You got to pick one. I don't know what to tell you. I mean, there you go. It's in black and white for you. You know that there's a rooster in a hen house here. They're greasing the skids for something. All right. So, back to, I don't think we went over this one yet. Hold on. The analysis of starlight from Cambridge and fundamentals of optics. Let's take a listen to this. Hot solid objects produce light with a continuous spectrum. Remember, we went over that above. Hot gases emit light at specific wavelengths, and hot solid objects surrounded by cooler gases show a near continuous spectrum with dark lines corresponding to the emission lines of gases. By comparing the absorption lines of the sun with emission spectra of known gases, the chemical composition of stars can be determined. See, they're screwing you right here. You don't even know it. You'd have to read it like 30 times to get the full screwing picture. I'm going to ferret those things out for you. Okay, so the sun is a ball of hydrogen gas? The sun in the second law of thermodynamics violation, is that a solid object? Huh? Ladies and gentlemen of the jury, you're witnessing a convoluted gaggle screw of epic proportions. And we're only at step one. If it's not a solid, is it a gas? If it is, how in the flying Fukuyama are you getting a continuous black body spectrum for a ball of hydrogen gas? How's that happening? Because remember our key learning objectives? Gas is only emitted in absorbent bands. How are you getting a continuous spectrum? Oh boy, the tangled webs they weave. This isn't even yet the major punchline I was talking about earlier. So, how in the flying Fukuyama are you getting a ball of hydrogen gas in a 10 to the negative 17 torr vacuum without bludgeoning the second law of thermodynamics to a bloody, lifeless pulp? That same goes for plasmas, by the way. Now, you need a container. If you thought all the above was a rootin' tootin' cluster gaggle of double-speak horse puckery, then somebody please hold all these bald tards' beards. Because here it comes, folks. You ready? From courses at Lumen Learning. Listen to this very closely. The dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun. What? Observing those wavelengths of sunlight. Because the space between us and the sun is pretty empty, astronomers realize that the atoms doing the absorbing must be in a thin atmosphere of cooler gases around the sun. We'll get to this part momentarily. I'm not all that concerned about that. I want to focus right here. Give evidence of what again? Well, they said certain chemical elements between us and the sun. Aren't we attempting to find out what the sun is made of? Not the stuff between us and the sun? There it is, folks. There's the full Monty right there for you. You want to see that again? Right? Does everyone get that? It's rhetorical. We'll probably have some questions. Maybe we'll do a break right now. Let me go over this again. From Courses Lumen Learning, the dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun. Yeah, really. That's wonderful. Of course, that's not what we're looking for, because you're telling us you know what the sun is made of. We don't really care what's between us and the sun. That doesn't tell us anything about what the sun's made of. Duh. Yeah, let me stop right there. Let me get some reaction with that. Questions, comments? Yeah? No? Maybe? Perhaps?
Yeah, Adam, go.
yeah, Adam, please say something.
Adam, go, please help me.
I was waiting for the boss. I was waiting for you, Betty. You know. It's not, I mean, to be honest, we have, as you say, gone over it in much greater detail in the past, and with the benefit of Dr. John Dee, whose PhD is in this subject. So, yeah, not a great deal to add other than just to reiterate the kind of point you're measuring. By their own admission of what they're doing, fundamentally they admit they're not even measuring the thing they're talking about, because they assume that it's a contradiction of what it's producing in the first place. But they by their own admission admit that the methodology they're using is telling them what's in between that full body and the observer, not what the body's made of.
Precisely. Does everyone get that out there? Hopefully you do, because it's freaking hilarious. Right? Even in their fairy tale paradigm, that's what we're in. It's giving you what's between us and the object of interest. We don't care about that. That wasn't what their claim was in the beginning. You said, Baltards, Evotards, you said we know what the sun is made of. Well, this is saying something completely different. Again, I could stop right here and prosecution rests. I don't have to do anything else. I just sit back and laugh, get my stogie.
Yeah, but even the judges are biased nowadays. So
Don't need any judges here. You're looking at it, with your own eyes.
I understand, but they are like blinded.
Yeah. But we're here to cure their astigmatism.
Sometimes I believe there is no cure for this and for blindness.
Yes, there is. My wolf pups got the cure.
Oh.
I have a
Before you
question.
continue, shall I shout out some super chats?
Please.
Yeah, I need to correct the one that Tony gave, because he later on said in the chat what he meant.
Okay.
With one of the words, he says the warping and bending of space-time, not Schwarztime, sounds like what happens in a baller's cranium. And then he said later in the chat, he said, addressed to me, my post was because I physically Globers would absolutely lose it mentally when you call out their beliefs and take away their fantasy ball fantasy. One guy even shouted help down the shop floor.
He did what?
Yeah, apparently he evangelizes a flat earth all over the place, and some guy shouted help.
Really?
Yeah.
What?
So
over the loudspeakers to the shop floor, like, help!
I have no idea.
Or help!
I sort of pictured that a ball is on the floor, like banging his hands and feet to the floor, and like a little child, help!
Yeah.
Like
That's just fanatical religitard escaping from the weakness of the body.
Yeah. Oh yeah. Well, we have come to that point.
Yeah, we have. Especially with this. This is really telling. I feel like staying here for a while. Just, floating around here. Let's do this again.
Yeah.
From courses at Lumen Learning. The dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun. Ha! That's not what the claim was there,
Did I
folks.
say that I was done with the super chats, by the way?
Take it.
Did I say that I was done with the super chats?
Oh, sorry. No, you didn't. You got more?
Yeah, I got more. I got lumpy gas in a vacuum saying, I've emailed 300 professors asking to justify lumpy gas in a vacuum. 0 or no reply. That's one. And another one was Goldie McKernan, and he posted a sticker of a flying Superman. Pear-shaped.
Let me check that. I'm sorry. Let me go check that out.
Oh, yeah. It's kind of cute.
Oh, that's pretty good. Super. Looks like a super, squash.
Yeah, I think it's a pear or something. Is
Pretty
the
cool.
Earth pear-shaped nowadays? Like maybe they try to make Superman a pear.
That's a long handle for a pear.
Yeah. Oh yeah, could be, right?
Hey, thanks for the
I don't
super
know.
chat, guys. Appreciate that. All right, let me get back. Yeah, I just wanted to hang out here. I like hanging out. It gives me a warm and fuzzy just hanging out right here.
Where are you hanging?
Shall I
God,
play Ball of Defense for a little bit?
please no.
No, because it kind of underlines another point. Because obviously, that's a real big contradiction, and they try to get out of it. What's the temperature, the supposed temperature of the sun? I don't know whatever it is. Anyway, they're trying to pretend that right next to this is a cold layer of gas, which can only have come from the same thing. And it's this that we're seeing.
Adam, we're gonna get to that. You're ruining it.
You mentioned that bit. I didn't think I was.
We're gonna get to that. I told you, don't worry about this part right here for the time being. We'll get to it.
Sorry.
But why mention this when we got this lovely little pig? Right? That doesn't mean you get to shut up. Listen, when you started talking, I opened up the banana, so continue.
I could tell you're on a banana. Okay. So even if then, see, and that's the point, I suppose. If you're not going to make apologetics for what that is, and all the claim is that we have a thin atmosphere of cooler gas, so just what can only be described as the stuff between what you're supposed to be observing. I suppose that is the crux of it, isn't it? That is the fundamentals of their claim before they try and twist it around. You've got to underline that point, that the way they understand it is that this is not measuring what the thing is. How they're going to reconcile it later is where I've overstepped. But the fundamental here is that they're recognizing that we're not measuring the full emission source. We recognize that the thing we're going to detect is what's in between it and us. In that banana by now.
No, no, it's right at the end.
No.
Can I ask a question real quick?
Was he eating a banana?
How do they distinguish what it is that's between? I mean, so they're saying there's stuff in between. How do they know what they're detecting? It's actually in between. It's not from the sun.
Yeah, we're gonna get to that.
Oh,
be patient. I just wanted to show you that this is utter ridiculousness from the get-go. And remember, the dark lines in the solar spectrum, that must be story B, because they told us before that it was continuous spectra. That's just, I'm majoring on the minors over here, but I thought I'd bring that up to you just so you'd remember.
That's the point, John, isn't it? Their claims are sun is full emission, yeah? It's emitting everything. They're saying there's gaps in it, and their explanation is, as we understand how cooler gases work, yeah, that they're the causation. Before they do anything to say what the sun is made of, they would be the causation if we've got a break in what we've defined as a full body emission. And that's where you're up to at this point, right?
So let me just say this. Let's say I have a ball of garlic, right? And I put some flame to it and it's on fire, okay? But we have a gas of pixie dust between us and the ball of garlic. What that absorption line spectra is going to give us an absorption line spectra of the pixie dust. It's not going to tell us about the garlic ball, even in their own paradigm. So, like I said, like I said, Evotards are blushing over this. I hope everyone gets this. I think I spent enough time. I think it burned into everyone's retina. And what I said was, can somebody please tell me what in the flying Fukuyama is going on here? I'd really like to know. All right, this is another good one. It's I already kind of sort of went over it. Now I'm going to give you more or less a pictorial version of this. All right, so let's check this out. So, and I didn't make this up, by the way. Right? So, it has the three different types of spectra that we went over before. Remember, continuous, absorption, and emission. Right? Continuous, and notice right here, I don't know why they don't have a sun here, but they got a light bulb. And by the way, folks, you see that filament right there? That's a solid, by the way. So, but I digress. So what I'm trying to say is a continuous spectra comes from solids, right? Especially when there's nothing in betwixt you and it. That's what they're trying to depict here. So you're going to get a continuous spectra. The next one is the absorption spectra. That is that same solid, but in line with you have a fairy tale second law of thermodynamics violating gas betwixt you and it. So you get an absorption line spectra. Now, this is supposed to be a cool, thin second law of thermodynamics violating gas, right? And then the third variety is the emission line spectra. That is that the light source isn't in direct line. It's radiating this second law of thermodynamics violating gas cloud, and you're getting an emission spectra. Guys, follow it. It's a pictorial representation of the juxtaposition between all the three emissions. I'm sorry, spectras. Okay, I want to focus on this one right here, the absorption line spectra, because this is what they use, even though NASA doesn't know that. This is what they actually use to grease the skids for their fairy tale story. So, like I said, you have a fairy tale sun, and in this case, they have this is a joke, a filament, a solid, and then a second law of thermodynamics fairy tale gas, thin, cool gas cloud. It has to be cool. It has to be close to the ground state, so when all that energy hits that gas, it has room to run into those higher energy levels, so they can absorb it. If they're already at a really high temperature, guess what? Those atoms don't have the capacity to absorb anything, so you're not going to get this. But I digress. That's just some background information. Hopefully the penny dropped for most people. So remember, this is a second law of thermodynamics violating cool gas. So, let's take their entire fairy tale story, and the sun is 93 million miles away, right? It's 93 million miles away from us right here. So, let's say that we have the light bulb go off, and we have the second law of thermodynamics violating fairy tale gas 3 million miles away from the sun and 90 million miles away from us. Are we going to get this same absorption line spectra? That's rhetorical. The answer is yes. Let's say that this second law of thermodynamics violating fairy tale gas cloud, thin, cool gas cloud, is 50 million miles away from us and 43 million miles away from the sun. Are we going to get the same absorption line spectra? The answer is yes. Let's say that this second law of thermodynamics fairy tale gas cloud is 10 million miles away and 83 million miles away from the sun. Are we going to get this same absorption line spectra? Yep. Hopefully everyone's getting it. Okay. Now, Adam's topic. He wanted to jump to the cool thin gases. Let's go there now. So see, cool thin gases around the sun? Friggin' where? Now remember, we're still in their fairy tale paradigm. We're going in there and chopping wood. According to them, the photosphere surface, and remember, gases don't have surfaces, is said to be 5,700 degrees Kelvin. The chromosphere is said to reach 500,000 Kelvin and is 10,000 kilometers thick. The corona is upwards of 10 million Kelvin and is 5 million kilometers thick. So where is the cool thin gases? I don't see any. You?
Those are big numbers.
So back again, we're going to Rochester Institute of Technology. Thin gases emit light of only a few wavelengths. We call this an emission or bright line spectrum. If there is a source of light behind it, a thin gas will absorb light of the same wavelengths it emits. We call this an absorption or dark line spectrum. We already went over those two above. The sun's atmospheric layers, so we're like he's stressing thin gases, right? Thin gases, right? So is this thin? The chromosphere is 500,000 Kelvin. That's temperature, by the way. And 10,000 kilometers thick. This is 5 million kilometers thick. Is that thin? Are the atmosphere layers of the sun cool or cold, or how about thin? See, nothing's lining up, right? I mean, what they're saying and what's actually done, or what they say they actually do, is not, there's a continuity error. Like 10 of them. This is a joke, folks. I'll tell you what. All right, so you think I'm making this up? You think this is QE's presentation? No. So what we're going to have Professor Voigt do from New Mexico State University, I'm going to let her hammer my case home for me. How about that? Would everyone like that? This is her diagram, by the way, that goes along with the presentation. So, without further ado, Professor Voigt, show that beautiful beam footage.
So now that we have the idea of colors going through the spectrum, and of a larger spectrum that contains colors of shorter wavelength or of longer wavelength than the human eye can see, we're going to take those ideas and apply them to spectra, figures or plots showing the dispersed light spread out as a function of wavelength, and we're going to consider the astronomical applications of spectra. So we begin by building on the atomic theory that we developed last week. We know that a given atom of some species will absorb and emit energy at the same frequencies. So if it absorbs a photon at a particular frequency and has an electron jump up one or several energy levels, inevitably it will emit the same amount of radiation when that electron decays down towards the lower or ground states within the atom. A cool gas of hydrogen atoms, for example, will produce an absorption line spectrum if it lies between you and your telescope and a continuum light source. So let's think about this and develop this picture a little bit. In our first diagram, on the left we have a white light source, something that emits smooth continuum radiation at all frequencies, and then we have a gas cloud. which is much cooler than the star and is filled with atoms, represented as small circles within the cloud. Our white light source, if observed directly, would produce continuum radiation, radiation at all frequencies. But what happens if we look at the star through the cold gas cloud? We know that the cloud is full of atoms. When we say that it's cold, we mean that the atoms contain electrons that are in low energy states, which would just love to jump up to higher energy states. So we see colored beams of radiation coming from the star in all colors, meaning that it's emitting light at all wavelengths or all frequencies. Those photons, which contain exactly the right amount of energy to enable electrons in the gas cloud to move from energy level to energy level, are the ones which are absorbed by the gas cloud atoms. So when we look at the star through the gas cloud, we see a continuum radiation source with light preferentially removed or absorbed at those key frequencies. So this is like a fingerprint. Once you match up the wavelengths that are missing from the continuum spectrum, you know exactly what elements were present within the cloud. Now you may wonder why the radiation is missing from the beam of light emitted from the star when you know that the atoms in the gas cloud will be excited and then de-excited. Let's think this through carefully. The electrons are elevated to a higher state within the atom, and then, given a little bit of time, they decay back down to the lower energy states. So in essence, all of the atoms in the cloud are absorbing and then re-emitting the energy which they take from the star. If that's the case, why doesn't that energy just fill in back the holes in the continuum spectrum, causing us to see a perfect continuum spectrum in our telescope on the right? The answer is very simple. Once an atom absorbs a photon, it loses all of the information about the direction in which that photon was traveling. The electron absorbs the photon, takes that energy to climb up to a higher energy state, and then when it falls back downwards, that photon is re-emitted in a random direction. This is the key point. And the result of this is that the gas cloud emits that radiation isotropically, meaning in all directions. It doesn't send all of the photons back along the beam of the star in the direction in which they were traveling before they were absorbed. Instead, they get scattered in all four directions to the winds. We can see this by placing another telescope, one that only looks through the gas cloud but that does not see the star. Imagine that the star and the gas cloud are separated by quite a great distance, as are the telescopes, so that we only see very narrow beams. Much as when you look up at the sky, one individual star only covers a very small angular distance on the sky. Now with our second telescope, when we look straight through the gas cloud, what do we see? Well, if there's no strong source of radiation present, if there's no star, we don't see anything. The cloud is cold, remember, and what that means is that it's not emitting energy on its own. The situation gets more interesting when we add back in the source of continuum radiation on the left. Once we do that, our gas cloud has a ready source of energy. It starts to absorb photons and re-emit them, and because it's re-emitting them in all directions, some of them are going to fall into a line that points to our second telescope. We don't see the continuum radiation from the star that passes through the gas cloud. What we see is only the radiation re-emitted by the cloud. So what we see now is an emission spectrum. At most wavelengths, there's no energy whatsoever, but at a few key wavelengths, those that correspond to the energy levels of the atom within the gas cloud, we have extra light. If you combine this emission spectrum with the absorption spectrum that we get by looking at the star through the cloud, the combination, in effect filling in the holes in the absorption spectrum with the emission spectrum, leads us to the original continuum spectrum. Light may be divided into two paths, but it's neither created nor destroyed in this process. It's a very elegant process. Now these three types of spectra, continuum, absorption, and emission, are the key types of spectra that we observe in astronomy.
Turn out the lights! Party's over! Clowns! You're finished! That's it! You're done! Just confirmed everything I just said. Unbelievable. Key learning objective, folks. Remember, this one never left us. Gases only emit and absorb in bands. Conclusions. belly-laughing bait-and-switch equivocation fallacy between terrestrial versus celestial spectroscopy. Number 2, NASA is unsure whether they're getting a continuous or an absorption line spectra from the sun. These bozos right here, the analysis of starlight from Cambridge, and Harvey and Francis here think the sun is a solid. And just the redheaded stepchild woodshedder from Lumen Learning, I'll say it again. The dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun. Game over. Just game over. Give evidence of what again? Well, certain chemical elements between us and the sun. Por favor, aren't we attempting to find out what the sun is made of? Not the stuff between us and the sun? My word. Can somebody please tell me what in the flying Fukuyama's going on here? Anyone? Bye-bye now. Questions, comments?
Super chat?
Let's do super chats.
Okay. So, where was I? Okay. What was with the sticker? Tony Whipcombe says, was the song I Am a Rock, I Am an Island by Simon and Garfunkel actually written by Michel Foller? LOL.
Yeah, it's a good one. We can always expect Tony just to come out of the blue with something and just start connecting things. Thanks, Tony.
Yeah. We got Godzilla 37, and he's how do workers stay in business when all the clowns work for NASA?
That's a very good question. Well, because they can stay in business because no one's paying attention, or very few are paying attention. That's why.
Yeah, but there's no clowns left. They're all at NASA.
There you go, folks. That's my presentation on spectroscopy or spectrochocoloscopy. It's a slam dunk. It's all over. Very quickly. Yes? No?
So, again, it's all over. It's been all over so many times, but slam dunkaroo.
So do they
probably ask
use the spectroscopy also in these so-called satellites that they send out to the star systems? And
I'm
stuff?
sure they do a lot in those satellites they send out to those star systems. I'm sure many things are going on there.
Yeah, but it's a vacuum, right? There's no air, no gaseous things.
You're just at the top of your game today, aren't you?
Well, the thing is that I was just watching Star Trek Voyager, and they claim it's a vacuum out there.
Did they actually claim it, or did they just portray themselves in it?
They portray themselves in it, and they come also through nebulas and that sort of stuff. So that might be some gaseous anomaly, maybe.
A nebula? This is a family show.
A nebula. What's wrong with the nebula again?
I don't see.
Oh, goodness gracious.
How any of the actual facts of the stuff that I think we'd all agree on their side, our side, how any of it demonstrates any of these amazing distances that they require. We have a emitting body, and we have an acceptance that we have information in terms of what's been absorbed. Both parties agree that what we're going to measure is not the body we're looking at, but the thing that going to be absorbed. We've demonstrated that the relative positioning of this thing that's going to do the absorbing is irrelevant. It could be near and far. If anything, we've demonstrated that the only place it can't be is very close, because it needs to be cool. So then that leaves me looking at both models. from the little data that I trust. I mean, there's claims that our upper air is constructed of helium and hydrogen, and these spectrums seem to be having absorption in those bands. So these things seem to be commensurate with certainly the flat Earth model. It doesn't disprove it, but what it doesn't do fundamentally is support the ball Earth model in any way. It only adds weight that there's contradictions within their model. Fundamentally, they've got gases emitting full emission. And the thing they're claiming they're measuring, like I said, even their experts deny that's what you're measuring. But to be able to draw that conclusion to me is the weird thing. But I think fundamentally it does not apply at any distances. Certainly not to the need of these astronomical units. I think I'm done. I've got another banana, have you?
I do not. One was enough.
But there's no scale you can apply to these results. Is the other point? It doesn't prove anything in their world. Like I say, it only disproves. And if anything, it's kind of telling you what's kind of the upper air is made of. Unless you're higher than that, and I don't know anybody that claims to be, unless you're looking at bubbly stuff, which is supposedly in a violation of thermodynamics. You know what I mean? So the reality is all these land stuff, this is what they're seeing. And so how do they preclude what they claim is already up there, which would produce that spectrum in and of itself?
I'm not chasing them down. I don't ask them any more questions. I already know many, many years ago what this deal was, and I just sit back and listen to. It's just the same story all over again. It's pretender clowns parroting stuff they have no clue of. They take the headlines and the spectroscopy. We know what the sun is. It's spectroscopy. They can't even spell the word. I'm focused on the ones out here in the venues that we entertain, right? I'm not even getting into the actual pseudoscientists, because these people out here, I remember I called them the left-wing fuckwit faction that just makes shit up. This just blows them right out of the water. You could just forget about it. If you mention spectroscopy around me, you're going to get a full case of an ass whooping. And it's going to come mostly by what's in this presentation. But the actual pseudoscientists, they're going to tell you straight up. Now, not NASA. As you can see, they contradicted themselves within the very same paper like 4 times. You can go to that link, too. I didn't make it up. So just go to that link and read the contradictions, right? It's basic stuff. A second grader can reconcile those contradictions. So there's 2 different populations that we're dealing with. We got the left-wing faction of anti-flat earthers that make shit up, and then the pseudoscientists. There's an unfordable like abyss between the two, right? So you have to take each claim that they make, either or, and then focus on that particular population group, if you follow what I'm saying. Each comes out to a train wreck. It doesn't matter which one it is. So,
Yeah, but maybe you're missing something and you're not that great of a scientist.
What am I missing?
Information.
Information? I already put all the information out to everyone right here.
Information that they have and they don't give you.
Oh, the secret knowledge.
Yes. Exactly.
Wouldn't you think that Professor Voigt, in her instruction to her class, would have kind of let the secrets out?
Did you say Voigt?
Voigt. That was her name, Professor Voigt.
Like Void?
It's Voigt, if I'm not mistaken. 1 second.
Oh, bad. Oh.
Not John Voigt, but Professor Voigt.
I liked it in the sense of void, like empty.
No, not void. See, void. No, I'm sorry. Now I might be mispronouncing this. Her name is Vogt. So maybe Vought.
Oh, okay.
I like Voigt because John Voigt.
Yeah.
So sorry
Okay.
about that. Yep.
I got some super for you.
More?
Continue. Yeah.
Honey.
Hmm.
I'm going to be in a very good place most of the day.
Yeah, I think so too, yeah.
Yeah.
So Unitux Pemu says on the circus thing, circus has also magician, animals, and acrobats. And then in another super chat he says, I didn't get it. Which color proves globe? And then we got Face Reality, another super chatter. And he says, how are we ever gonna figure out a way to get to and explore the true north and true southern areas, Antarctica, 3D problem? Yeah, that's true.
It's not a problem, and thanks for the super chat. We really don't need to, because the globe Earth
Yes,
is.
we do. We want to know the boundaries.
Well, not we, because I don't.
Yeah, you don't. You want to be in a cage. Yeah, that's true.
I don't want to. I'm not in a cage, love. Now, if you're interested in,
now
stop rumpusing me. Now, if you want to, that's you personally, and the general or royal you out there, you want to go and explore those areas, more power to you. I'm not saying don't do it. I'm just saying for me personally, number one, I'm getting older nowadays. My adventurous ways have kind of left me with second law is directly responsible to that. That's number one. Number two, I don't need that to prove the Earth is flat, non-rotating, stationary. I don't need that.
No, but some people like to explore, and they took that away from us.
And contained. Sorry, forgot that last part.
Yeah. Did you hear what I said?
I didn't. I was screaming.
Yeah, I know. The thing is, people like to explore, right? And they take that away from you when they are putting treaties in place.
That's true.
Yeah, which prevents you to ever go anywhere, right? And know for yourself, come to the truth. In a stupid way, they just keep us here.
I can see the point, right? And I stand.
I know it doesn't involve what you are talking about right now.
Yeah,
but it's still interesting.
Yeah, it doesn't, but it's something that we needed to talk about because he super chatted it.
Yeah, well, yeah, and I think I agree with him. I wanna know what there is there too.
You want to explore? What you gonna do? Get on a boat and then a donkey?
I don't know. I don't know if a donkey will do great on ice.
Are you a hiker?
No, I'm not. I want to be comfortable in a plane.
Oh, you want to do it by plane in a recliner, getting your first class meals.
Nah, not that big of a plane. It could be a little smaller, little propellers.
Ozark Mountain Shed Wings.
Yeah. Well, I want to just fly over it and see what is happening there.
What's that? Okay. Well, fair enough. Like I said, you're right that that is the human spirit.
Yeah.
The exploring part, I understand that. Like a child, I got it. Right. That's all I did when I was a kid and younger. Yeah.
I think that these people that were like exploring Africa and all parts that I didn't know, like America, were like little childs.
Not child, but a childlike fascination with exploring. I can understand. I can relate to that. I used to remember days like that.
Yeah, but not only childlike, like exploring new grounds, new places to be.
Yeah, it's childlike fascination, love. You're not listening to what I'm saying. Not that, not that you're a child or those people are children exploring, but a childlike fascination with the idea of exploring and the practicality of it. Follow?
Yeah, love.
I didn't think they were stopping you going there because they had something to hide. I thought it was to protect the penguins.
Yeah, I think they have bigger ones than once you go down more on the ice. What do you think?
All right, guys.
I'd love just to address that question. I'd love to know more. I don't think it's within the remit of us YouTubers and likes to are gonna crack that kind of nut. Yeah, we have to break the paradigm in society, and then we will explore these things and see what's there. You know what I mean? But it's not. I don't think for some damn foolhardy mission of flat earthers to hire a boat, some ice-breaking boat, and head south. I don't know what that would yield either way. You know what I mean? So it's lovely, as you say. You have that desire, that fantasy, but I think reality, that's not the best way to expend your energy. And having said that, right, when we first started Iron Realm, yeah, there was a guy that was touting stuff and contacted us. He was trying to sell these tickets for 200 grand. I reckon there was this Southern Treaty thing and all these things. There's lots of fantasy out there for you to do, because that's the point. It is unknown. You know what I mean? And it's natural to ponder, I think. Whether we're ever going to do it, I don't think so. Not until lots of other things are corrected. So, and then it won't require flat earthers. It'll be our society's exploring it again, like when you described going down into Africa and exploring and etc. and mapping stuff out there. That's what I think the last time we went down there was Admiral Byrd, and that's very dubious as to how real that was.
Yeah, I would love to have talked to the guy, or at least read some of his notes, right, that he made.
I don't think we'll ever. I don't expect it in my lifetime. I mean, it's not something, I think, as John said, I'm not asked. I agree with him, because it's not something that's within my remit. Yeah, I'm actively prevented from going there. Like I said, sarcastically, under the guise of protecting penguins. But for whatever reason, I'm not allowed there. I am precluded from going there, and that's intriguing. It doesn't prove a great deal as to how much more or less there's there. It's intriguing because it would allow you to undefine the parameters of a ball if you had a bit more freedom. Because remember, it's only 60 degrees. There's still a lot more that they're limiting, and I'm sure penguins don't occupy that much space. And how much damage could a crisp packet do on one little yacht? You know. For the reasons I think are invalid, and obvious that they're invalid. So we're precluded. That's the point. On purpose, with great threat and, you know what I mean, obstruction. So why waste your energy there? What are you going to do?
Yeah, but that's the whole point. Why are they doing it, and why can't we go there? And what is there to protect except the penguins, right? Or the penguins? So yeah, maybe there's more land after all, right? Maybe you can go on into another realm.
We all know what's past there. New Schwabia, the new Germany.
Yeah.
Yeah.
Yeah. God. All right, I got another super chat, by the way, from Tony Whitcomb.
Oh,
Can
really?
I shout it out?
Yeah, go.
He says, Phil B to me, that's the Phil in the chat, I think. Stop sipping methanol. That's what he has in his arsenal, he says.
Yeah, that's what they all have. I don't even know why he's out here anymore, Tony. I mean, if you go to the Numpty clips, by the way, I was listening to a whole bunch of those. I don't usually do that, but something led me this morning to go back to the Numpty clips, so I just started randomly picking Numpty clips. I'll tell you what, those things are friggin' hilarious. We're listening to them over again. So what I'm going to do, and I know this is off topic a little bit, but it's not. It's connected. Just entertain me. What I'm going to do is, and I did it today, I played one of the numpty clips in the beginning of the show. I think I'm going to start doing that. Say for BALLBUSTERS, but QE Live will do the numpty, most of the numpty clips at the beginning of the show. So, well, thanks a lot, Tony. I appreciate it. And that's all they got. He's just, Phil B is the poster child. If you go and listen to his numpty clip, you're going to be asking yourself how he's not institutionalized. I mean, it's that bad. Wait, if you listen to it again, I mean, it's retarded times 10. He should be picking up cans. Boy. He should be picking up cans alongside of the road. Supervise.
Hey.
Damn, I got rumpus.
Sorry. I thought you'd done. I didn't know you were going to super vote it. I didn't know you was going to throw that out. I was just going to, it's about Phil. That's what you've been looking at chat, right? And we've done a really nice presentation. Well, let's see, very royal that, isn't it? John's done a really cool presentation. Is there any point in there that he's addressed that he feels a rebuttal, or has he just resorted to that because, God damn it, that's devastating?
No, he ain't got. He doesn't have anything. He's an empty dipshit.
That's very telling, isn't it? After something that's in his field, isn't it? It's his specialty, and instead of addressing anything in it, we get
his specialty.
Yeah, well, space and stuff, isn't he? He's spaceman.
That's his.
He's full of shit.
That's specialty. The space. Are you talking about that which is betwixt his ears?
Well, there's a lot of that as well. Probably more than what's supposedly out there. There's definitely some between his ears. But did you get me? The point is, like, what you detailed there was very, very detailed and worthy of rebuttal if you had some to address the very valid points. But nothing, absolutely nothing.
Nope, just ad homs.
Yeah, it's just weak and very, very telling.
Yep.
Whether you like, whether we like Phil's specialty or not, it is spacey. He must have covered all of this stuff. He must know the contradictions himself. He's got nothing to say. No QE. X, Y, Z. There's nothing there at all, which is, to me, a very good tacit acceptance from him.
Yep.
Especially if all it does is retort with Adhom.
Yeah, it's a tacit do 7 offsuit. Yeah, we already know you got that. That's why we call all in. Yeah. All right, Betty, let's wrap it up. Let's go through each question.
Yeah, I got a suggest before we do that, so let me do that one first.
Go ahead.
Yeah. So Unisox Fame starts talking German to me now. Es wird bekannt gegeben, die Erde ist eine Scheibe.
Okay, translate, please.
It has been known, described. The Earth is a flat disk.
Is that what it says?
Sort of.
Wait.
I can't know all the words. That's it's sort of different way how we verbiage that. So.
I'll tell you what, you said it sharp. I'll give you that.
Yeah, I live on the other side of Germany.
All right, let's go through them, Betty.
All right. Yeah, I think I start at Johnny B because he came in specially from the chat to Discord, so I will give him the mic. Johnny B, you wanted to talk to QE?
Yeah, I hope the push and talk is working. I have to hold in my spacebar.
You can change that up if you want to, but this works, so let it be like this.
They said I have to use the push and talk. It's very, very okay. I am doing that now. I'm holding in my spacebar. So that I want to ask QE about is he knows about the light, or especially laser light, is invisible through vacuum. Yes or no?
So I didn't. Did somebody understand what I didn't understand you, Johnny.
Oh shit! I'm just saying. I will know if you agree with me. If light is invisible through vacuum.
If light is enabled through a vacuum, did I hear that correctly?
Invisible.
Betty,
you cannot see.
I've got it, John. I've got it.
You got it. I'm sorry,
light.
John. I just can't understand. Go ahead.
Wow.
That's all right.
Invisible. You cannot see the light
just
through
relax. Hold on.
vacuum.
Just relax, Johnny. Adam's come to save us. Go ahead, Adam.
Oh.
John is saying, is it correct that light, the traversement, the traveling of light as it moves, is it invisible in a vacuum? Correct,
is it
Johnny?
invisible in a vacuum? Yeah, light's invisible until it hits something.
Exactly. Then we agree with each other. And do you think then a light is a particle?
Do I think that I didn't hear? I can't hear him that well.
Is light a particle?
Yeah.
It's like, oh, you a flat earther?
Yes, I am.
Yeah, my policy as of about a year ago is to not discuss light with flat earthers. Sorry.
Yeah, but you have changed your mind now, or?
No, I just don't discuss it with flat earthers anymore.
Okay, so you have no answer, but you can.
I have an answer.
But
I'm not into this. I'm not, Johnny. I'm not doing this now. Do you got a question on spectroscopy? That's what the presentation was about.
Okay, spectroscopy is about we need a chamber. We need do it in a lab to get a real result of to get real result. We need a chamber in a lab to get what's the fucking name? Telescopy.
Yeah, terrestrial spectroscopy is done in a closed system in labs. It's not science. There are no experiments. What they're trying to find is identification of substances. That is answers to what is questions. Terrestrial spectroscopy is legitimate.
Yeah, okay, that's the same thing I am thinking also. But what is the answer with people that think you can use it through the layers and through all the layers, through the atmosphere and in a long distance? How can we answer so stupid? No scientific.
It's very difficult to answer that. You just use my presentation and then corner them. That's
I'm sorry, I was not in the beginning of the presentation. I will look up at it afterward.
Oh yeah, there's big points in there, and when they mindless spectroscopy, what the sun's made of.
It's funny.
Yeah,
I love it.
I've given you all the ammunition you'll ever need, and they're like hydrogen bombs.
Okay, I like it. But do you think there's not something real behind the atom bomb?
Oh, I ain't getting into bombs. No, that's outside the scope of our discussion here today.
No, I will give my opinion. I think it's impossible that they can, through the Chinese missile, they can send something like they are saying. I think that is a fucking bluff. I think that it's impossible.
Okay.
I cannot understand it.
All right, fair enough.
Fair enough. Thank you very much. Thank you.
You're welcome.
Great. Thank you.
Yep, you're welcome. Matt I'll get him, Betty. Oh, you got him.
Oh, I got him. Yeah. I'm paying attention for once.
Hey, everybody. Learned a lot. The sun's a solid. The sun's a gas. It's got a thin and thick atmosphere and a second law of thermodynamics violation.
Yeah.
It's got a continuous spectrum with emission spectrum. You know, it's almost as if they could get us to double think, they'll get us to double speak.
You got it, man.
And yeah, I mean, professing to be wise, it seems like foolishness.
Exactly. Very well done. Thank you. Is that all?
I think so.
And remember, the most important thing they're trying to figure out, even in their paradigm, that they're actually testing what is in between us and the sun, not what the sun's made of.
Little hide the ball. Which cup is the peanut under?
Exactly. It's too funny, man. All right, Matt. Thanks. Go ahead, Betty.
And we go to Neil. Neil, what are you doing? Neil. He's not there. Okay. You lost your chance.
I put Platter on mute because I was getting background noise from him. Platter, you got to be careful of that. But go ahead, Betty. You can get him.
I unmuted him. Platter.
Oh, hi guys. I joined really late, so I'm going to have to listen to the recording later on to catch up on spectroscopy. I have no idea what it is. I had a ZX Spectrum computer, but I don't think it's anything to do with that. I did catch the very end there where you guys were talking about the Antarctica Treaty. The only question, can I ask one question about that?
Yeah, I suppose.
Why do they not have a treaty for the North Pole like that to stop exploration there? Because it's a totally different dynamic there.
Good question. I don't know.
I think because of the magnetic field iron ship, you will never ever be able to get there because the whole compass is going screwy.
Good point, Betty. They don't fly over the North Pole
And
either.
you get a lot of icebergs and all kinds of hazardous stuff that happens first before you get there. So you will not
I
ever
would
get
point
there.
out, Betty, that there are no penguins in the North Pole.
Exactly.
There you go.
You don't get the treaty.
Yeah, I think just one last thing. I think it is. When I was growing up with the globe and everything, it's like I used to be disappointed that there was no exploration left on Earth, and then to realize, hold on, there's so much more exploration to hopefully happen one day. Even here, we don't need to worry about space. There are still lands to be discovered here, possibly, and it opens up that boyhood adventure again in me.
Yeah.
Yeah.
Thanks very much, guys.
Yeah. No. Appreciate it. You noticed, Betty, you didn't say girlhood. You said boyhood fascination.
Boyhood. So?
That's
girls
all.
can't
That's the only point I had.
Girls can't explore? You mean that? You say that to me?
Yes.
Oh, if they're getting the cooking, cleaning, and ironing done, they haven't got time to do it all, have they?
Oh, we have you, Adam. You can do that.
No, I can't. I've got 6 days. My wife's going to Italy tomorrow. So it's me and the boys for 6 days. It's going to be chaos when she returns. There'll be no cooking, cleaning, or ironing done. There's all these gender questions at the moment. What is a man? What is a woman?
Oh, God.
Babylon B did a nice one. What is a man? A man is somebody who, even having been told which shelf it's on, can go to the fridge and not find the milk.
Can't even bake an egg.
That wouldn't be me. No. That's a stereotype that has not rang true.
It means that you're a woman now, John. So you just came out with that.
I'm not a woman, but I can cook.
You are a woman.
I'm not a woman.
You're baking eggs, or you're now a woman.
Baking eggs?
Mm-hmm.
I don't bake eggs, love.
Whatever you do with them.
All right, somebody save us. Our Duncan.
Oh, did I unmute you?
I did.
Oh, okay.
Hello.
Hello.
Hello, that's profound.
I just woke up, so
okay.
not really caught up on the conversation. But I do have a question.
Good.
Where are you?
Okay, I got a couple. I guess I'll start with one. So, when SpaceX is flying up to wherever, like it obviously curves, but what really interests me is I'm always interested in like miles per hours and because I've always been into racing, so I'm like, oh, I want to go faster. I want to see, I like the velocity. I want to see like how much force is like happening. So I always see these jet aircrafts, and they have G-force, right? And the pilots are inside, and they have to do all these tests and all these G-force tests, and they're going like super fast, Mach whatever, and their face is like flying back. They're about to pass out. But meanwhile, you look in the SpaceX launch, and these guys are they're going like 2,000, 3,000, 4,000 miles per hour. And they're just sitting there like they're enjoying their cup of tea. Like nothing's happening inside the cockpit.
All right. I got you, Art Duncan. Hold on, Adam, before you start chasing that tail. During this presentation, I'd like to discuss stuff with spectroscopy. When I have shows with like open discussions, this is a good topic to go into. Not that it's still a good topic. I just want to like distill it down to what we're somewhere in the vicinity of what we were talking about today.
Oh, definitely. Yeah, I just woke up, so it was just a random question that was like very broad, and
right,
just no one's answered it. Yeah,
I got you. But Adam, so you're not chasing any more tails, so we'll deal with that. Just remember that question and bring it up the next time we have an open discussion.
Okay. Yeah. Cool. No problem.
Cool. Thanks.
One more quick one. It's not that long. So I've seen images of the sun going through clouds. Can anyone confirm that? Or video, sorry.
I've seen images of the sun going through clouds. It looked just like the sun was going through a cloud.
Yep.
Right, yeah. It's just kind of interesting.
Really?
Yeah, of course I have. I've seen lots of weird things.
Betty, I think Neil's back.
Well, it looks like the Empire State Building is smaller than buildings maybe 1,000 feet in front of it when I'm at a distance.
Yeah, Neil, right? Eli showed me pictures, right? Looking down New York avenues at somewhere where it looks like the sun is going between two buildings. It's mental. Yeah. It's the brightness of the light. It's overlapping some of the buildings. Kind of work out it's probably not.
All right. Is that it, R. Duncan?
Called perspective, right?
Thanks, Neil.
That's cool.
Is that it, R. Duncan?
Yeah, I'll come up with some other stuff next
time. Yeah, just chill. I'm going to have a open discussion or open panel here shortly, so make sure you come back in, and I want you to ask those questions, okay?
Awesome. Thanks, brother. Have a good one.
You too. Sasha, thanks for the super chats, man.
Sasha? Are you there?
Sasha, you're off mute, but we are not hearing you, brother.
Maybe we need to do a super chat. You're unmuted, Sasha.
Yeah. All right, Sasha, we'll get back at you here in a few. Scrat is flat. Did we go over, because you did ask a question in there or made a comment, and did I go over that topic?
The one that I asked?
Yes.
Yeah, well, actually I didn't hear, because a lot of the second part of your presentation, just before you played the clip of that professor, you were roboting for me almost like 80% of the time, so I didn't catch anything.
Oh,
and
really?
I didn't even hear her. Yeah, I didn't even hear her presentation, because I'm just on Discord or something.
Okay.
I don't know.
Was I roboting for anyone else besides Scrat?
Some of the times it looked for me also a little scrambled, not all that much, but sometimes. And so it could be a Discord thing and not a OBS YouTube thing.
Okay. Sorry about that, Scrat. So if you want to ask your question again, go ahead.
Well, how do they distinguish what? Okay, first of all, when they took these measurements or whatever, were they on Earth, or were they using a so-called satellite?
No, they were using the McMath Pierce telescope that's during the presentation from Kitt Peak.
So it is looking through our atmosphere.
Yes.
Okay. All right. So how do they distinguish what's actually between instead of? How do they know stuff between us and the sun and not the sun? Obviously, some of it has to be because it's our atmosphere, but I don't know. This just doesn't make sense to me.
Well, because they're getting an absorption line spectra, so it has to be something in between the sun and them. That's just what it is. That's
okay,
what.
So they could actually see both of them, the continuous and the absorption.
No, you're getting one or the other. And I went over the scenarios. If you go back to the presentation after the show's over, I went over. I spoke to it, then a pictorial representation twice. Once on my own, and then the fine professor did a presentation on it.
Yeah, I think those are both that I missed. Okay, so I'll just not ask any more questions then.
No, that's okay, man. Go over the presentation, and if you have any more questions, just hold off till next Tuesday. You could PM me, that's fine, but come back next Tuesday. Write them down, man. Okay? Is that good? Yep.
Yes, sir. Thank you.
You're welcome. Go ahead, Betty. You got two more you can do to hammer first.
Yeah, hammer. Let me unmute you. I saw you come in later. Did you watch the show, the presentation?
Yeah, I apologize. I came in late again. Maybe my question would be, now that you're on normal time, what time do you normally come on? Because I keep missing you.
Right. Okay, let's solve. I'm going to solve the mystery for everyone. For QE Live, the Tuesday shows are always going to be at 1300 or 1 p.m. U.S. Central, 7 p.m. UK. Ballbusters every other Saturday. That is going to be 2 p.m. U.S. Central, 8 p.m. UK.
You said that Ballbusters is every other Saturday, and then this QE Live is every weekday?
Yes, every Tuesday.
Yeah, unless the computer
every Tuesday.
unless the computer is out.
Yeah.
And that happened a couple of weeks. Your computer was down, wasn't it, QE?
Yeah, and I got a flash today, so that it's got me a little bit concerned, but it seems like everything's going okay other than for the little roboting.
Yeah, okay. So Hammer, are you on one of the Skype groups? Usually there are announcements there as well.
Nice. Sorry, I was just walking out, but yeah, I appreciate that. Hope everybody's having a great day, and I'll catch up on the show.
Hold on. Now, she asked you a question. Are you in one of the Skype groups?
Oh, no, sir. No. Sorry, I was walking out the building, so I probably didn't hear that.
Okay. Do you want to be? Because there's usually the announcement being made. So.
Yeah, I'm not sure I have Skype, but you can send me the link if you want or whatever.
And I post them in Discord also in all over Betty's server.
Yeah, in Ballbusters usually, I think, too.
No, I put them in live. I put them in main and Ballbusters.
Maybe we should put an event so that you can. There's a new feature in Discord that you can sort of pop up and see that there's an event going, someone going live.
Okay.
Okay. So Hammer, do you want to shout out your channel, because you have a YouTube channel as well? I know that you were streaming from here as well from time to time.
Oh, yes, ma'am. Yep. I've been starting that. I'm trying to get it going, trying to get some consistent times going, like you're saying you're having. But yeah, it's just called The Hammer. It might be kind of hard to find. I'll have to get better on that, but that's about it for now. We're just kind of trying to, be supportive and in this argument and kind of bring some cohesiveness or some coherence to it, maybe a little less craziness and shouting.
What's your channel about? Is it like a talk show kind of thing, like we have at the panel, or
Yeah,
is
pretty
it?
much. We're
Do
just
you
kind
also,
of. Oh, sorry.
do you also do
Sorry.
video presentations, that sort of stuff?
I'm working on that. So the production level is constantly getting upped and upped as I'm learning. It's kind of a learning in progress kind of thing, but hopefully we're definitely going to get to that point.
Okay, good. Yeah, always nice to see new people starting, right?
Yeah, appreciate it. And like I said, hope everybody's having a great day.
Thanks. Right, I think we got them all now. And the last but not least, of course, is Adam.
Pretty succinct tonight, really. I don't think there's anything to add to. I want to add to the presentation. Just say to Hammer, look, drop your channel in the Discord chat here, and we'll give it a shout out next week, and also on Flat Earth Debate, mate.
Thanks, I appreciate that. I will.
Oh, and you got Nathan's show starting in 10 minutes. So everyone check the YouTube chat. He's got a brand new Flat Earth Debate 1664 uncut and after show. 10 minutes.
Well, pin it. Pin it in the chat.
I can definitely do that, can't I?
Yeah.
Thanks.
Yeah, but we try to sort of elevate Hammer's channel a little, right? That was nice. So if everybody wants to go to his channel, you can also post the link in the YouTube chat, in the live stream chat, if you want to, Hammer.
Yeah. Then if I pin that, then it'll take Nathan's pin away. Yeah, no problem.
I don't want
Nathan.
to trump Nathan.
It's not. You can go ahead and post it in there. Did you give him permissions to do that, Betty?
You need to give him permissions to do that, because I don't know if you can post a link. If you're not a moderator.
He could post it in BALLBUSTERS chat here, and then you can post it in YouTube.
Okay, yeah, that's good. Oh, it's
I'm on it now, guys.
Okay, appreciate it.
He's just posted one, so I'll stick this into the YouTube chat now.
All right. Thanks, Adam.
There you go, guys. That should be Hammer's channel there. And I'll subscribe, mate. Good luck.
Please, yeah.
All right, Betty, take us home.
Yeah, it's good to have people start new YouTube channels and also on this topic, right? The more we spread out, right? Like sort of an ink stain, right? Then the more people we can reach, right? So we need to get the network going. Yeah, I think it was a great presentation. At one point, I saw that there were like 77 people watching at the same time.
98.
So nice. Did you see that?
Yeah, 98 was the high, I think, but I really don't trust the numbers. I really don't want to get into this discussion, but I don't really trust those.
True, but it has been somewhat lower, so this is good, right? So people, I hope that everybody will like get these sort of presentations out to family, friends, Facebook, Instagram, whatever. You can sort of get people to watch these, and yeah, we need to sort of get away with the pseudoscience and get to the truth, because nowadays it's more important than ever, I think.
I agree.
Can I just add one thing? This one, like I said, it was brilliant. There was nothing for me to add content-wise. This is the one I requested. And the reason being that this is the thing that was claimed to have taken Flat Earth apart when David Weiss was challenged on this topic. Now, I just want to say, if Dave had listened to the previous things and had this information at hand, he wouldn't have been able to have had the ballers claim he destroyed him. He'd have definitely destroyed them. Listen to what's there, use it. It's really, really powerful, and it's all their own rhetoric that destroys them on this one. It's beautiful. Yeah, cheers, John.
Thank you, sir. Yep. Last shots, Betty.
I think I said enough.
Okay. Thanks, guys. Thanks for the panel. I hope you got a lot out of the presentation. If you have any questions or stuff, or you go through the presentation again, make sure and write them down. I always tell people to do that so they can remember the questions and then bring exactly that topic up again. So go through the presentation. There's a few of them out there. I think, like I said, this is the third or fourth on spectroscopy. Trying to make them more concise as we go. So I hope everyone got a lot out of here. There's a lot of ammunition here for any crayon munching window licker that starts to stumble around and talk about, we know what the sun is made of. Yeah, bring up spectroscopy. It's like a big, fat, hanging watermelon-sized curveball for you. So I hope it helps. I'm out.